All right, today we're going to be talking about parallel lines and what it means for two lines to be parallel. So we're going to look at this top example up here really quick. So I have two different colored lines. I have the orangish one, and then I also have a green one. Okay, so let's say we were writing equations for these lines. Let's start off with the orange equation. So I'm going to go ahead and color in a box orange. And we know that when we're writing an equation for a line, there's a couple forms we could choose, but let's go ahead and write this in the form y equals mx plus b, where m is our slope and b is our y-intercept. All right, so for this first one, y equals, we know we're going to have an x and either a plus or minus b. So I'm actually going to leave it as plus because we can also add a negative number. So let's look for our m first, our slope, the number being multiplied by x. So when we're looking for slope, the best way to look at it from a graph perspective is to do the rise over the run. So let's say I have 2 points on my line, and I'm going to do rise first, because you always have to stand up before you start running. My rise, assuming each block is 1 unit, is going to be 2. And my run is 1 unit. So my slope is 2 over 1x plus my y-intercept. So this is where it crosses the up and down axis, the vertical axis. And that's going to be right here at y equals 1, 2. So my y-intercept's at positive 2. Now I'm going to go ahead and rewrite this equation because it's always great to make your equation look pretty, simplify it. We know that 2 divided by 1, that's just 2. So my final equation is y equals 2x plus 2. All right, let's do the same thing for the green equation. Then we can kind of spot some similarities and differences between them and what might make them parallel. So for my green equation, I'm going to do the same exact thing. I'm going to have to find a slope, and then I'm going to be either adding or subtracting a y-intercept. So let's look at slope first. We're going to choose 2 points on the graph. Why don't we choose this one and this one? Sure. And we're going to do, of course, our rise over our run. So I'm going to rise up 2 units, okay? And I'm going to run 1 unit. So my slope is 2 over 1. And where does it cross the y-axis? Well, let's see. I'm going to go down. It crosses right here at -1, -2. So -2. So again, let's make this equation prettier. We know that 2 divided by 1, that's just 2. X, because x's are multiplied. And then I'm adding -2. So you can either subtract 2 or add a -2. They both mean the exact same thing. So I'm actually going to write both of them. 2x minus 2. Now, if we're looking at the final orange and green equation, and we're looking at what they have in common, what they have different, and it looks like that they have the exact same slope, but their y-intercepts aren't the same, which is okay. What it means to be parallel is they're going to go the same slope forever and never touch, which makes sense. It's kind of like a constant race. If I'm going up 2 over 1 for each of these, they're constantly like racing each other, but they're never, ever, ever going to touch. So parallel lines have the same slope. So this is in the form y equals mx plus b. It's the one being multiplied by x. It's the number that m represents. All right, so let's do the same thing for the second one. The second graph, I also have 2 more lines, and we're going to check to see if they're parallel. Well, I know that I need to first kind of look at their slopes. That's what makes them the same. I don't need to necessarily write the equation to make sure that they're parallel. I just need to make sure that their slopes are the same. So let's go ahead and find the slope of the orange first. And I'm going to choose 2 points on the line. Now, if you're like, I don't know what points to choose, Well, you want to choose 2 points that are on grid lines. So where like these blue lines all over my paper are, you want to choose right where they cross. So here's where they cross once. No, they don't cross there. Don't cross there. Ah, they crossed right there though. And I like doing my points from left to right just to make things easier. And you always have to do your rise over your run. Your slope, your M, is your rise on top, your up and down on top, and your run on the bottom, the side to side. So from here, we're going to rise down first. So that's going to be a -3. Don't forget that negative. And then I'm going to go +1 in the right direction. So this slope is -3 over 1, which we know -3 divided by 1. Anything divided by 1 is just itself, so it's going to be -3. And now we just need to make sure that the green one has the same slope. So again, I'm going to choose points where the grid lines intersect. And let's see, I'm going to go down 3. So that's going to be -3. And then +1. So my slope does end up being the exact same, meaning that they are parallel. So keeping it in mind that parallel lines have the same slope. If you're given a word problem that says find a line parallel to an equation, let's say y equals 2 over 5 x minus 1, and it says to write a new equation that's parallel to it. So I'll abbreviate it parallel equation. We know that parallel lines have the same exact rise and run. They have the same exact slope. So if 2 over 5 is my slope here, 2 over 5 has to be my slope down here too. And then it really doesn't matter, like we saw up here, it doesn't matter what our y-intercept is. So maybe your favorite number is 17. So you want to add 17 for your y-intercept. That works.